In this video, we're going to break down exactly how to develop an app using vibe coding. We'll go step by step through the entire process, from setting up your environment all the way to generating a fully functional app with AI.
Okay, so let's dive right in. Here's the game plan. We'll kick things off with the essentials, getting your setup right. Then we'll actually create our project and the database. After that, and this is a big one, we'll configure something called the MCP server. Think of it as the critical link that lets our code editor and our database talk to each other. Once that's solid, we'll define our app's data structure. Then comes the fun part, using AI to generate all the code. And finally, we'll fire up our new application and make sure it's properly documented.
Okay, so first things first. Before we can even think about writing a single line of code, we've got to make sure our local development environment is dialed in and has all the necessary tools ready to go. So here's our toolkit, the absolute must-haves. You've got to have Node.js, and that's non-negotiable because the MongoDB MCP server, which is basically the bridge to our database, it runs on Node. The rest of the stack, well, that's what we'll use to build the app itself. Python, the Streamlit framework for our UI, and a couple of key libraries like PyMongo to actually talk to the database. All right, with all our tools installed and ready, let's get to the next piece of the puzzle, creating the actual foundation for our project. We're going to build this out both on our local machine and up in the cloud with MongoDB Atlas. You know, the process here is actually super straightforward. You literally just start with a plain empty folder on your computer. Then you pop over to MongoDB Atlas, create a new project, and boom, it automatically spins up a cloud database cluster for you. The last and absolutely most critical piece is to grab that connection string. That string is the magic key that lets our application talk to that new database. Okay, now we get to what I think is the most interesting part, making that magic connection happen. We're going to configure the MongoDB MCP server. This is the piece of the puzzle that lets our code editor, Cursor, communicate directly and intelligently with our MongoDB Atlas database. This was a real game changer. Now for this part, you'll want to follow these steps to the letter because it's super important. You're going to grab two little snippets from the Atlas user interface. One is an installation script and the other is a configuration file. You'll paste that config into a specific settings file inside Cursor called MCP.js. Then you just swap out the placeholder with your own unique connection string. Give Cursor a quick restart, toggle the server on and off, and just like that, the bridge is built. And this is exactly what you'll be looking for. This slide highlights the one line in that configuration file you need to edit. See where it says password? That placeholder has to be replaced with the actual password for your database user. If you're not sure what it is, don't worry, you can find it or just reset it right in the database users section of your Atlas project. All right, so you've followed all the steps, you're sure you did everything right, but the connection just isn't working. Don't panic. This is a really common hurdle, and there are a few standard things to check before you start pulling your hair out. Okay, here's your troubleshooting checklist. Honestly, 9 times out of 10, the problem is a security feature. You just forgot to add your current IP address to the Atlas access list. Super simple fix. If that doesn't do the trick, try a complete restart of the Cursor application. And if you're still stuck, you can even ask Cursor's built-in AI to help you figure out what's wrong. Pretty cool, right? Okay, so our editor and our database are now officially talking to each other. Awesome. The next step is to define the structure of our data. In the world of MongoDB, this means we're going to create collections, which, if you're coming from a SQL background, are pretty much like tables. So you basically have two fantastic ways to do this. The first approach is what we call vibe coding. You just describe what you want in a simple prompt to the Cursor AI, give it some sample data, and it'll figure out the whole database schema for you. It's pretty amazing. But if you want more granular, precise control, you can always go the manual route. Just log into Atlas and define the collection structure yourself using a sample JSON document. And this brings us to the heart of it all, the most powerful part of this entire workflow, using AI to generate the entire application code based on nothing but our requirements. Listen, the quality of your prompt here is everything. You can start with something pretty high level, just like the example you see here, or you could literally paste in a detailed multi-page requirements doc. The key takeaway is this. The more specific you are about the tech stack, the database structure, and the features you want, the better your results are going to be. So instead of the AI just immediately dumping a wall of code on you, you can use this feature called the plan. And trust me, this is a total game changer. What happens is the AI first gives you a structured, detailed breakdown of its approach.
It explains its reasoning, shows you the file structure it's planning to create, and gives you a to-do list of every step it's about to take. This gives you a chance to review everything and make sure it makes sense before a single line of code gets written. So this whole workflow, plan, build, commit, it really puts you in the driver's seat. You get to review the blueprint first. Then you give the green light to build, and you can literally watch as the AI generates all the files right there in your project folder. Finally, you commit those changes, and just like that, you've officially accepted the AI's work into your project. All right, we've got our code, our database is connected, our structure is defined, we're in the home stretch. The final phase is to actually bring this application to life and make sure it's properly documented for whoever comes next, which might just be you in 6 months.
You know, one of the best parts about this is that the AI almost always generates a readme.md file for you, and that file is basically your personal instruction manual. It'll tell you exactly which dependencies you need to install from the requirements file and give you the precise terminal commands you need to run to get the application server up and running. And that brings up a really critical point. Good documentation isn't something you should just tack on at the end if you have time. It really needs to be part of the development process from the get-go. And you know what? With an AI-assisted workflow like this, it becomes incredibly easy to do. This is where you can see how to leverage the AI for a lot more than just writing code. For example, you can export your entire chat history with it, every prompt you gave, every response it gave back, as a single markdown file. I mean, that's a perfect, detailed log of your project's entire evolution. You can even ask the AI to review the README it just generated and suggest ways to make it even better. So the real takeaway here is to think bigger than just simple scripts or small tools. When you combine a really structured setup, a powerful connection between your editor and your database, and this transparent AI planning process, well, this workflow can handle some serious complexity. So the real question to ask yourself is, which one of your most complex projects could you seriously accelerate with this kind of approach?